Hey everyone, welcome back. In this video I'd like to do a comparison between two 12-inch woofers, and I'd also like to propose a new test method for measuring intermodulation distortion. Before I get started, what I'd like to do is read a quote from Philip Newell's book on recording studio design, 4th edition. So on page 523 he says, very much more work still needs to be done on the reduction and meaningful measurement of IMD, so intermodulation distortion. One reason why there has been a lack of motivation by many commercial manufacturers in audio equipment has been that because of the lack of accepted specifications, they have been reluctant to pursue expensive improvements that cannot be proved in the sales literature. A meaningful, subjective correlation measure would be a powerful stimulant to the global attack on the IMD menace. Nevertheless, it is probably true to say that the perceived clarity in any audio system is usually a direct result of the absence of intermodulation distortion. So this has gotten me on a little bit of a quest to find really effective way at measuring intermodulation distortion, and so I'm going to touch on that a bit in this video. And I'm about 5 videos behind on my content on YouTube. I've been pretty faithful with posting regularly on my blog. However, I would like to get the content out there on the YouTube platform so that I can reach out to this audience as well. So let's get started on my comparison. So I'm just going to quickly go through the test data between these two woofers. These woofers represent two ends of the spectrum in terms of you have a subwoofer with the Dayton, and it's typically going to cover from around 30 hertz up to around 80 hertz. With the Aton, it's more of a woofer category that's capable of playing into the mid bass. However, I pose the question on whether or not you can use the Dayton into the mid bass region from say 80 hertz up to 300 hertz, and what test data supports that decision to use it for mid bass as well. So looking at the specification differences between the two drivers, you can see that the Aton is much more sensitive at 93 dB sensitivity, and then the Dayton is only 85.7. So this is a result of the much higher X-max on the Dayton, so you're going to have much more of the coil outside of the magnetic gap, and as a result of the increased X-max, you also have much more power handling, which is a direct relation to the X-max. And so if we look at the frequency response between the two drivers, there's nothing that really comes to light as far as what the intended bandwidth could be for these drivers, other than the fact that the Dayton does go lower into the bass. They both have similar breakup, starting at around the 500 hertz mark, which below 500 hertz there isn't any mechanical breakup in the diaphragms, so we can't draw any conclusions from this. Looking at the step response, we do see that the Aton has a much quicker decay, but again, do we know if that is a limitation or not for the Dayton in terms of being able to produce a clean mid bass? Looking at the burst decay, we're left again not being able to draw any conclusions. So if you wanted to look closely at the two, you could argue that the Aton is showing some resonances at around 110 hertz. You can see here, and then there's the second part of that resonance is showing up again at 220 hertz. So if the Dayton is actually looking cleaner in terms of the spectral burst decay that I've shown. Looking at harmonic distortion, you can see here that there's nothing really jumping out at us. And again, if you want to make the argument, it looks as though the Dayton has lower distortion. Even when we start to get into the 500, 600 hertz range, the Aton is starting to have an increase in the third harmonic. Increasing the SPL from 90 to 95 dB, again, nothing really conclusive. It's just showing that the harmonic distortion is lower, well below 0.3% with the Dayton. Jumping up to 100 dB SPL, again, same result, nothing really showing except that around 100 hertz for the Aton, we're creeping into around 0.7% harmonic distortion. And I should make a note here too that my testing is strictly done with an eye towards sound quality for hi-fi home listening. And so I'm not looking at maximum SPL capability. It's strictly in terms of sound quality. And so with these tests, I'm only looking at the part of maybe the linear part of the behavior of the driver. So, within maybe 25% of the overall X max of each driver. So we're not even close to the maximum output of each of these drivers. So when it comes to intermodulation distortion, I decided to devise my own test. And so with intermodulation distortion, you have two frequencies that you play simultaneously. So typically those frequencies are very far apart. So you would have, for example, a 500 hertz note and then a 10 kilohertz note. But for my design work, it's often I'm working with very narrow bandwidths, particularly with horn speakers, which a horn is only going to cover maybe 2.5 octaves of sound. And so what I've done is I've ran a series of multi-tones, and so I conducted a test where I played, so F1 would be 20 hertz, for example, and then the second frequency, F2, would be, I simply multiplied it by the golden ratio, which is 1.618. And so the reason I chose the golden ratio as my multiplication factor is because it's not harmonically related to anything with sound. So it's not like I'm multiplying the frequency times 2 or times even 3 or 4. 1.618 seems like a good litmus test against identifying intermodulation artifacts. So you can see here that the F2 is 32 hertz, and so I simply played those two frequencies at the same amplitude, and then I observed the artifacts that are generated. So when I say artifacts, I mean what I refer to as sidebands. So you see here that there's sidebands that are generated from, it's a mathematical relationship between these two frequencies. So for example, the highest artifact produced is it's simply F1 plus F2. And so that would be a non-harmonically related artifact in the sense that it has nothing to do with the music. It's not going to get masked by other harmonics. So like when you have an acoustic guitar, there's going to be harmonics generated outside of the fundamental string note. And so a lot of times harmonic distortion can be completely masked because it's hidden inside of those natural harmonics produced by the instrument. And in fact, for example, second harmonic distortion can actually sound more full. It can be some people can subjectively perceive it as something that's pleasurable and enjoyable. However, intermodulation distortion is not related to any harmonic, and so it's going to be very objectable, and it comes across as a reduction in clarity, like the quote that I mentioned at the beginning of this. And so you can see here that even further up in the bandwidth, we have products that are very significant. And so simply down in the bottom corner, and I'm using ARTA as my measurement software, you can see here that there's 2.81% intermodulation distortion. And so I simply went through and conducted a series of 9 tests where I produced these frequencies as I went from the bass region into the mid bass and into the mid range, and I plotted the distortion number that you see down here in the bottom of the screen. And so I had to use Excel to plot a chart. And so the resulting chart that I gained from that is shown here. And so you can see the difference between the two drivers. The Dayton consistently had lower intermodulation distortion through the 9 test points. And so along the horizontal axis you have the frequency, and then along the Y you have the intermodulation distortion. And so this brings to light a distinct difference between the two drivers, where before in our previous tests it wasn't conclusive on what driver would be suitable. And so what does this mean? It suggests that the Dayton, although it is a subwoofer, it potentially could be used as a woofer as well to cover even more bandwidth into the mid bass. So that concludes my video. I'm going to publish more content coming soon that discusses intermodulation distortion. I'm going to do more comparisons between different drivers, and hopefully this will bring to light a measurement metric that strongly correlates to subjective sound quality. Thank you and have a great day.